Sorry for that. Never too sure when my stream actually starts. Okay, it seems to be working now. We'll jump straight into it. Just give me a sec to share the thing. Need to really automate this sharing business, but then the whatever websites might not like it. So block you for automating this stuff. I mean, yeah, what's called YouTube has its own one sec. So posted that. It's asking me if I want to post in another group, which yeah, I'm never too sure if I should or should not. So we'll do another hour. Just to have longer live streams, but now we keep them to an hour or less. I think my voice is a bit better now. Okay, so we have this tool. It's a synthetic EEG signal generator that we're trying to bring back. Now we're using Flask, NumPy, SciPy. That's working okay. We're just trying to fix a few little annoying things in it, like this timing changes from 10 seconds to well, from 5 seconds to 5,000, which is not good. Not much. So we probably need to start a new chat. We're using GPT-4 Advanced Data Analysis. It's to be called the code interpreter. Turn this for a sec. About 100 lines of code. Is 70, yeah, 100 lines of JavaScript and 110 of Python. I have to start a new chat because whatever files you upload or code you upload, it forgets about it. It's unfortunate. So I have to do it again. Can stop generating that. It's a JavaScript, and yes, someone will be screaming at me for not just uploading all the files together as a zip. So I did try it before. Problem with that is that the GPT doesn't seem to read the files. So I'm not sure how useful that is. Yeah, I don't need the breakdown of this script. We would like to continue developing this code. Let's start with that.
Absolutely, let's continue developing this code. Here's a breakdown of the current structure and some suggestions for further development. Initialization. The script initializes a Flask application and sets up default values for parameters like window size, amplitude, and bandwidth for different EEG frequency bands. Generating synthetic EEG data. The generate_synthetic_EEG_data function generates synthetic EEG data based on the provided window size and amplitude parameters. It uses a custom chirp function to create individual components for each frequency band, delta, theta, alpha, beta, gamma, and combines them to create a synthetic EEG signal. Custom chirp function. The custom_chirp function is a helper function used to generate individual frequency components. It uses the chirp function from the SciPy signal module. Flask roots. The script defines several Flask roots. Update_parameters, a post root that updates the EEG parameters based on user input and returns the new synthetic EEG data. The default root that renders the main web page using a template. Get_EEG_data, a get root that returns the current synthetic EEG data. Error handling. The script includes error handling to deal with potential issues that might arise during the parameter update process. Enhanced signal generation. Currently, the synthetic EEG signal is generated using chirp signals. You might consider using more complex methods to generate synthetic EEG data that more closely resembles real EEG data. Frequency band power calculation.
We actually want to use inverse F noise for that.
The JavaScript code mentioned a function to calculate the power in different frequency bands. You might consider implementing this functionality in the Python script, perhaps as a separate function or endpoint. The Python script interacts with a front-end application. You might consider further developing the front end to include features like real-time updates, user-friendly controls, and more detailed visualizations. Consider adding unit tests to verify the functionality of your application, especially the parts that handle data processing and signal generation. The current method of generating signals using chirps is quite basic. We can enhance this by implementing more complex signal generation algorithms. Consider using more sophisticated algorithms for generating synthetic EEG signals that mimic real-world EEG data more closely. Adding noise. To make the synthetic data more realistic, consider adding an option to include noise in the generated signals. The JavaScript code mentioned a function to calculate the power in different frequency bands. We can implement this in the Python script by implementing Fourier transform. Use Fourier transform to calculate the power in different frequency bands. Visualizing power spectrum. Enhance the front end to visualize the power spectrum in addition to the EEG signals. Step 3. Front-end development. We can enhance the front end to provide a better user experience. Real-time updates. Implement real-time updates so that the charts update automatically as the parameters are changed. User-friendly controls. Develop user-friendly controls for adjusting the parameters. Detailed visualizations. Include more detailed visualizations, such as a spectrogram, to provide more insights into the data. Step 4. Testing. To ensure the reliability of the application, we should unit tests. Develop unit tests to verify the functionality of the application. Integration tests. Develop integration tests to verify the interaction between the front end and the back end. Step 5. Documentation. As the code base grows, documentation becomes crucial. Code comments. Add comments to the code to explain complex sections. User guide. Develop a user guide to explain how to use the application. API documentation. Create API documentation to explain the endpoints and the expected input and output. Step 6. Error handling. To provide better debugging information, we can enhance error handling by detailed error messages. Provide detailed error messages to help identify issues more easily. Error logging. Currently, the EEG signals are generated using chirps, which are linear sweeps of frequency. We can consider generating more realistic EEG signals using different algorithms or mathematical models. Here, I'll introduce a method to use sine waves with varying amplitudes and frequencies to generate more complex signals. To make the synthetic data more realistic, we can add a noise component. Here's how you can add Gaussian noise to the signal. 2.1 Implementing Fourier transform. We can add a function to calculate the power spectrum using Fourier transform. Visualizing power spectrum. We would need to update the front end to visualize the power spectrum. This could be done in the JavaScript code, using the data returned from the new calculate_power_spectrum function. Absolutely. Let's proceed with calculating the power spectrum using the Fourier transform and then visualizing this data on the front end. We can use the Welch method to estimate power spectral density, which is available in the SciPy signal module. First, let's implement the function to calculate power in different frequency bands. Now, modify the generate_synthetic_EEG_data function to also return the power spectrum data. And update the Flask routes to include the power spectrum data in the JSON response. Next, we need to update the JavaScript code on the front end to visualize the power spectrum. You can add the following snippet to your update charts function in your JavaScript code. This will create a line plot on an element with ID spectrum chart to visualize the power spectrum. You might need to adjust the element ID and other properties according to your existing HTML structure. Once you have implemented these changes, you should see a new chart on your web page displaying the power spectrum of the synthetic EEG data. Let me know if there's anything else you'd like to add or modify. This will create a line plot on an element with ID spectrum chart to visualize the power spectrum. You might need to adjust the element ID and other properties according to your existing HTML structure. Once you have implemented these changes, you should see a new chart on your web page displaying the power spectrum of the synthetic geek data. Let me know if there's anything else you'd like to add or modify.
So it's not updating when it should. And there's something wrong with the power spectrum. Why is it only going up to 6? Going up to 6 hertz, I don't know why. Yeah, there's a lot of problems. This. Yeah, I would like to
Absolutely, enhancing the front end to provide a better user experience is crucial. Let's address each point step by step. To implement real-time updates, we can add event listeners to the input controls so that the parameters are updated and the charts are refreshed automatically as soon as a user changes any input value. Here's how you can do it in your JavaScript code. To develop user-friendly controls, consider the following. Tooltips. Add tooltips to the controls to provide users with information about what each control does. Input validation. Add input validation to prevent users from entering invalid values. Responsive design. Make sure that the design is responsive and looks good on all screen sizes. Including detailed visualizations such as a spectrogram would provide more insights into the geek data. You can use Plotly's capabilities to create a spectrogram. Here's a basic example of how you might create a spectrogram using Plotly in JavaScript. Note that creating a spectrogram involves computing the Fourier transform of overlapping windows of the signal, so you would need to implement the Fourier transform function to compute the Fourier transform of each window of the signal. Once you've implemented these changes, your front end should provide a much better user experience with real-time updates, user-friendly controls, and detailed visualizations. Certainly. Let's take it step by step to rewrite and enhance your EEG signal generator application. Here, I'll provide you with updated versions of each section of your code, considering the improvements discussed previously. Here is a portion of your HTML file updated with tooltips for better user experience. This is a portion of the JavaScript file updated to include real-time updates and a function to create a spectrogram placeholder. Note: in the Python script, the synthetic EEG signal generation now includes sine wave components for different frequency bands and adds Gaussian noise to the signal. The tooltips in the HTML template provide users with information about what each control does. The JavaScript file has been updated to include real-time updates and a placeholder function for generating a spectrogram. You would need to implement a Fourier transform function in the JavaScript file to create a spectrogram. You can use a library like Fourier, JS for this. Please replace your existing files with these updated snippets and further enhance them as necessary. Let me know if there's anything else you'd like to add or modify. In the Python script, the synthetic EEG signal generation now includes sine wave components for different frequency bands and adds Gaussian noise to the signal. The tooltips in the HTML template provide users with information about what each control does. The JavaScript file has been updated to include real-time updates and a placeholder function for generating a spectrogram. You would need to implement a Fourier transform function in the JavaScript file to create a spectrogram. You can use a library like Fourier, JS for this. Certainly. Here's an updated version of your charts, JS file, incorporating the changes and improvements discussed. Changes made. Updated the update charts function to also handle the power spectrum data and plotted. Added a placeholder function create spectrogram to create a spectrogram visualization. You will need to implement the Fourier transform function to actually compute the spectrogram data. Added event listeners to the input controls for real-time updates. As soon as a user changes any input value, the parameters will be updated and the charts will be refreshed automatically. You can add this code to your charts.js file. The spectrogram function is a placeholder and you would need to implement or integrate a Fourier transform function to compute the spectrogram data. Let me know if there's anything else you'd like to add or modify. The frequency range in the power spectrum going up to 500 Hz is likely because of the default settings of the Welch method, which is used to calculate the power spectral density. The frequency range in the output is determined by the sampling frequency and the number of points used in the FFT, fast Fourier transform, which are parameters of the Welch method. In your code, when you call the Welch method, you can specify the fs, sampling frequency, parameter to control the frequency range in the output. The Nyquist frequency, the maximum frequency that can be measured, is half the sampling frequency. In your existing code, the sampling frequency is set to 1000 Hz, hence the maximum frequency in the output is 500 Hz, half of 1000 Hz. Here's how you can adjust the fs parameter to change the frequency range in the output. In this example, I set the sampling frequency to 500 Hz, so the maximum frequency in the output will be 250 Hz. You can adjust the sampling frequency according to the range of frequencies you are interested in. Would you like to modify the sampling frequency or any other parameter in the Welch method? The issue could be due to several reasons, such as a JavaScript error, a server-side error, or an issue with the event listeners. To troubleshoot the issue, let's try the following steps. Check console errors. Open the browser's developer console, usually F12 or right-click greater than inspect, to check if there are any JavaScript errors being logged in the console when you change the input values or press the button. Verify server response. Check the network tab in the developer console to see if the post request to update_parameters is being sent correctly and receiving a successful response when you change the parameters. Review event listeners. Ensure that the event listeners in your JavaScript code are correctly set up to trigger the form submission when the input values are changed or the button is pressed. Server-side logging. Add print statements in your Flask root handlers, update_parameters and get_eg_data to log the received data and the response data. Here are the steps you can take to identify and fix the issue. Check server logs. In your terminal where the Flask app is running, check for any error messages or stack traces that are logged when the post request is received. The error message should give you a clue about what went wrong. Exception handling. Make sure that your update_parameters root handler in the Flask app has proper exception handling to catch any errors and log the full stack trace. You already have a try except block which catches exceptions and logs the stack trace, so you should check the server logs for any stack traces. Request data format. Verify that the data Absolutely, here's the regenerated code for your index, HTML file, incorporating tooltips to provide more information about each control. Changes made. Added tooltips to various elements like the window size input, amplitude control section, bandwidth control section, update button, and the egg charts. These tooltips provide users with more information about what each control or section is for. The tooltips are added using the title attribute in the HTML elements, which displays a tooltip with the specified text when the user hovers over the element. Please replace your existing index.html file with this updated version, and let me know if there's anything else you'd like to add or modify. Certainly. Here's an updated version of your charts.js file that includes improvements such as real-time updates, more detailed visualizations, and user-friendly controls. Changes made. I've separated the code for updating parameters into a separate function named updateParameters, which is now called both when the form is submitted and when any input value is changed, facilitating real-time updates. The updateCharts function now also handles power spectrum data. Note that you might need to implement a function on the server side to calculate the power spectrum based on the EEG data received from the server. I've added error handling to the fetch call to log errors to the console. You can replace your existing charts.js file with this updated version. Let me know if there are any other changes or additions you'd like to make. Absolutely. Here's the regenerated app.py file, incorporating proper error handling and ensuring it interacts correctly with the updated charts.js. Changes made. Removed unused imports and added an import for the Welch method to calculate the power spectrum. Updated the generate_synthetic_eg_data function to generate synthetic EEG data with components for each frequency band, delta, theta, alpha, beta, and gamma, and calculate the power spectrum using the Welch method. Updated the update_parameters and get_eg_data roots to return the calculated power spectrum along with the EEG signal and time array. Added error handling in the update_parameters root to catch any errors and return a 500 response with the error message. You can replace your existing app.py file with this updated version. Let me know if there's anything else you'd like to add or modify. The error message you provided indicates that there is a type error occurring in the generate_synthetic_eg_dat function, where it's trying to multiply an untype, none, with a float. This suggests that one of the amplitude values you are receiving from the front end is none. This could be happening because the data sent from the front end might not be correctly formatted, or there might be a typo in the name of one of the keys, causing the value to be none when you try to access it in the dictionary. To fix this, you can do the following. Ensure that the names of the keys in the JavaScript code map to names of the keys you are using to access the values in Python. Add validation to check that all the values you receive from the front end are not none before you try to use them. Here's how you can modify your generate_synthetic_eg_data function to add validation. This will raise a value error if any of the amplitude values are none, which will be caught by your exception handling in the update_parameters function and returned as a 500 response with the error message. Also, make sure to verify the data being sent from the front end in the update parameters function in your charts.js file to ensure that all the values are correctly formatted and not none. Certainly. Here's an updated version of the generate_synthetic_eg_data function with added validation to check if any of the amplitude values are none, and to handle it appropriately. In this version of the function, we check if any of the values in the amplitude dictionary are none, and if so, raise a value error. We create a dictionary freq_bands to define the frequency ranges for each band, which is used both for generating the EEG signal and for grouping the power spectrum values into bands. We use a loop to generate the components for each frequency band, using the amplitude values from the amplitude dictionary and the frequency ranges from the freq_bands dictionary. We calculate the power spectrum using the Welch method and then group the power spectrum values into frequency bands using list comprehension. This version of the function should prevent the type error you are encountering and correctly calculate the power in each frequency band. Please replace your existing generate_synthetic_eg_data function with The error is occurring because the frequency_bands list contains strings like delta, theta, etc., and we're trying to use these strings as keys to access values in the freq_bands dictionary, which has keys like delta, theta, etc. The keys are case sensitive, so delta is not the same as delta. To fix this, we can update the list comprehension that calculates power_by_band to use the correct keys to access the values in the freq_bands dictionary. Here's the updated part of the function. In this version, we create a frequency_bands dictionary that maps the capitalized strings to the lowercase keys used in the freq_bands dictionary. We then use this dictionary to get the correct keys to access the values in freq_bands within the list comprehension. Replace the respective section in your generate_synthetic_eg_data function with this updated code, and it should resolve the key error you're encountering. Let me know if there's anything else you'd like to adjust or add. Absolutely. Here's the updated generate underscore synthetic underscore eg underscore dat function with the corrected keys for accessing the frequency bands. In this version, we have a dictionary frequency underscore bands which maps the capitalized band names to the lowercase keys used in the freq underscore bands dictionary. This allows us to correctly access the frequency ranges in freq underscore bands when calculating the power by band. The function returns the list of capitalized band names along with the other calculated values. Please try using this updated version of the function in your script, and it should work without the key error you were experiencing earlier. Let me know if there's anything else you would like to update or modify. The error log indicates that the generate underscore synthetic underscore eg underscore data function is receiving none values in the amplitude parameters, which triggers the value error we defined to catch such cases. This suggests that there might be an issue with how the amplitude values are being sent from the front end or how they are being processed in the Flask route handling the post request update underscore parameters. Let's ensure that the data being sent from the front end contains valid values for all amplitude parameters. You might want to print the data received at the back end to debug this issue further. Here's how you can modify the update underscore parameters route in app.py to print the data it receives. After making this change, try sending a request from the front end and check the console for the printed data. Verify that all the amplitude values are valid and not none. If the problem persists, you might also want to check the front end code, specifically in charts.js, to ensure that the amplitude values are being correctly retrieved from the input fields and sent in the post request to update underscore parameters. You might want to add some console.log statements in charts.js to print the data before it is sent in the post request to verify this.
Okay, I might just continue next time. I'm getting too many errors. I'll see you tomorrow.